conversation is going to be an awesome dinner conversation as well as JWST. Okay. I am the timer. This is for all of you. I am the timer, the advancer. Although some people have bills and they need to advance. If you have a bill and you need to advance, just tell Adam and you advance. But then he may tap you on the shoulder if you go too long. Let me get my timer ready. It's gonna beep. It's gonna make a good sound. Who's just gonna be up first? Hang on, not ready yet. Hold on, it's just like we're meeting, guys. Yeah, this goes. All right, ready, folks? Are we ready? Audience? All right, Buddha. Buddha's up. Okay.
Hi, Fuda Nguyen, second year grad student at University of Arizona, working with Daniel. Are there polar vortices on brown dwarf atmospheres? The answer might surprise you or not. In this work, we created a 3D spatial model of brown dwarf atmospheres that encode different spectra into different latitudes of these objects, assigning to different cloudiness from pole to equator, just like on Jupiter, for example. And we simulated time series spectra and show that polar vortex are actually consistent with the color inclination trends that are collected in observations previously. And our model motivated for more observations. So yeah, come check out my poster, number 27.
And no applause, please, between. Just take it. Give a big applause. Yeah, this is just poster prop standards.
Hey everybody, I wanted to advertise some exciting results from a JWST Director's Discretionary Time program to image AFLEP-B with JWST despite it only being at 300 milliarc seconds from the star. Super challenging, 2 lambda over D away from the host star already makes it super challenging, but we're also dealing with the coronagraph. And so at AFLEP-B's separation, over 90% of the light is blocked by the very instrument that's blocking out of the light of the star. And so we're really pushing the instrumentation to its limits here. We, of course, convinced ourselves that we could do it. Here's the prediction of what we thought our imaging might look like. And then here is what we actually observed. Come check out my poster.
Yep. Okay. Nope. I'm wrong. Somebody else.
That's me. No. Hiya, I'm Keane O'Toole. I'm looking at 3 variable brown dwarfs, and you can see they're very variable in those lovely curves there. They're exoplanet analogues for a very famous one, Beta Pictoris b. So if you're ever wondering how variability looks or like how atmospheres look on brown dwarfs that are similar to exoplanets, these are 3 very good ones. And that picture there in the far left, that's actually a brown dwarf. Not quite HD, but as close as you get. Thank you.
I'm Sarah Moran. I'm a postdoc at the University of Arizona, but I'm moving to Goddard as a Sagan Fellow in the fall. I'm showing you right here some condensation curves of cloud species we think are common across exoplanets. Now I'm showing you PT profiles of various substellar objects. And now I'm showing you the different crystal forms that should be stable at different temperature regimes. So it's not enough to think about amorphous versus crystal. We need to know what kind of crystal. I got some optical properties for these things to put them into an atmospheric model, and that's what it looks like. And if you want to know what it means, you should come talk to me at my poster.
Hi, I'm Eileen Gonzalez. I am an assistant professor at San Francisco State University. Most important, my poster is going to be up so you can look at it and not online. That's up Wednesday through Friday. I'm doing atmospheric retrievals with Brewster. You heard lots and lots about Brewster in the earlier retrieval talks. So I'm looking at 2 widely separated a binary system, an L plus a T. To cut it short, the answer is both of them want clouds. If you want to find out what kind of clouds they are and what they might be, talk to me.
Federico Marocco, IPAC. So over the last few years, tens of thousands of citizen scientists have been relentlessly blinking WISE images and have found hundreds of new cold brown dwarfs. Now, the follow-up of those brown dwarfs has revealed, as you have seen in this session, an incredible diversity. In my poster, I'm highlighting a few of the most exciting discoveries, which include, but not limited to, the accident, 1534, possibly the first Y subdwarfs, ROS19b, possibly the first Y dwarf companion to amine sequence stars, and 1935, which shows methane emission in its spectrum. Thank you.
Hi everyone, I'm Thomas. I'm a PhD student at the Université de Montréal. I work with Loïc Albert, who's leading a program to search for white dwarf binaries below the diffraction limit of the telescope with something called kernel phase interferometry. So kernel phase means that we're using interferometric techniques on regular images that gives us access to companions very close to the primary. As you can see here, we're sensitive to 3 Jupiter masses at 2 AU with 90% completeness. Come talk to me at my poster if you're interested in any of this. Thanks.
Somehow I have double my poster up there. Anyway, we've heard about the problem separating metallicity from gravity, and I'm finding that the 5 to 10 micron color is very sensitive to gravity and not very sensitive to metallicity. So it looks like that's going to be a really powerful tool for us. We have to shift over to thinking about 10 to 15 micron wavelength science. And yes, we do need to push to beyond to longer wavelengths.
Hi, I'm Anna Zuckerman. I'm a PhD student at CU Boulder working with Sebastian Pineda. I've been interested in how aurorae work on brown dwarfs. Basically, aurorae have been detected on brown dwarfs, but they don't necessarily look how we might expect them to. So if you're interested in hearing about my model of energetic electron beams in brown dwarf atmospheres, feel free to talk to me. I have poster 64 today and tomorrow.
Hey, everybody. Kelly Cruz, based in New York City, BDNYC Museum of Natural History, CUNY Hunter College, and I want to talk to y'all about the simple archive database, which has been mentioned. What I really want to do is facilitate all this awesome parameters that you're deriving and data and help us, both you advertise your own data and to share it collectively. One of the things I want to show is that at the bottom, the database is text files, which you can edit using GitHub. So we can collaboratively do it easier than we have been in the past. Talk to me so you can add your own data.
Hi everyone, my name is Aniket Sanghi. I'm a first-year grad student at Caltech. We heard from Sam Byler today about the importance of measuring fundamental properties and the white dwarf revolution with JWST. I've compiled the largest sample of MLT fundamental properties, nearly 1,000 plus objects, and derived their luminosities, uniformly their ages, and then gotten their effective temperature, radii, and masses. All of this data is publicly available on the ultra-cool sheet, and you can use it. Come talk to me at poster 113, Wednesday to Friday.
Hi everyone, I'm Emily Rickman, astronomer at Space Telescope Science Institute. This is basically a general plug for caring about benchmark brown dwarfs. What am I talking about? Brown dwarfs for which we have dynamically constrained masses, so we're not relying on models. So that looks like combining radial velocities with astrometry and imaging. I have a whole bunch of these, so check out my paper or come chat with me. But we can also get spectra of these objects as well. We're doing this with gravity of interferometry. But come cycle 3, JWST, myself and Daniela here are going to be leading a program where we're going to be looking at 10 benchmark brown dwarfs. So yeah, come chat to me about it.
Hi, everybody. My name is Daniela Gagliuffi. I'm an assistant professor at Amherst College. And if you thought that it was hard to figure out the properties of one spectrum from JWST, let alone 2 that are blended together, we don't know either one, but we're trying really hard. So my poster is fully online, very ecological. And so we have some fits, we have some data from the same program, and just come talk to me later. It looks good.
Hi everyone, I'm Clémence Montagnier, University of Montreal. I don't have a poster about science to advertise, but I do have a conference poster to advertise. So if you care about exoplanet atmospheres, brown dwarf atmospheres, or the atmospheres of any sort of worlds, Jack is happy. The next iteration of the Exoclimes meeting is going to be in Montreal next summer. So save the date, July 7th to 11th. The week before, there's going to be a 2-day workshop about exoplanets atmospheres as well. And I'll be talking about white dwarfs on Thursday. So there's more white dwarf stuff to come. All right.
About how do we understand the data so far?
So Stephen's asking, this is for those on Zoom, you're gonna have to run this mic because otherwise they can't hear. If we need more theory. So Caroline, Jonathan, Mark, do you want to say something here? Because I'm gonna give you this mic so that people on Zoom. I'll keep talking so much of silence, but I'm gonna hand this to you.
My first brown dwarf forward model paper was in, I think, 1986. And I kind of feel like we should be done by now. But clearly we're not, right? And I think the thing that we're missing is taking the retrievals and really trying to nail down what's wrong or because if you took one of these retrieved profiles and then based on our framework for understanding these things, and if you built a brown dwarf with the retrieved profile and let it go, the forward model physics would say it would change to something else than what the forward model thinks it should look like. So the fact that there's this difference, which is great that we're starting to get at that, but my answer to the question is there's a real disconnect and we have to fix that before we really can make progress into understanding the whole framework and what does the composition mean, and does it really tell you about origins, and all that stuff kind of comes back to the fixing the theory. So that's my 2 cents.
Who's gonna fix it though, Mark? Like, who's gonna fix it?
Not me.
You don't have the grad students?
Yeah, I think we need a couple of dozen objects with the kind of resolution that gets us we need vertical abundance profiles, and all these vertical abundances, I think, is part of the reason that, we saw that beautiful profile comparing the forward model to the retrieve model today. But how much of that difference is because the retrieval is assuming constant abundances? And so can we map out how we get vertical just like we saw in the variability talk, beautifully, there's different levels in the atmosphere we're seeing to. Can we pick 3 or 4 levels in the atmosphere, get abundances at those, and maybe we don't need as much data, but we just focus on getting the vertical abundance profiles for the 5 or 6 key species. Yeah.
I think we're gonna have some data that's gonna be helping that we just haven't gotten to yet. There's a couple of variability programs, but can you get to Sam back there? And for those on Zoom, you're just gonna have to deal with me not being heard. They'll be fine with it, I'm sure.
So actually I have 2 pain points I would like get solved at some point. In our WISO 359 paper, we noted that with the alpha models, they were fitting extraordinarily well from what we'd expect, aside from a couple issues with the alkali and the phosphine. But past 11 microns, there was this huge difference between the model and observations. And I'd love to see more data about what's driving that, what possibly might be doing that. And then also one thing I didn't have time to talk about, but we're seeing a offset between in the 3.6 Spitzer data, where the observed Spitzer magnitude is off by about 0.3 magnitudes for the late T and Y dwarfs. And we've shown that the calibrator stars are not having that issue. So somewhere between an F4 star and our T6s, there's this drop off in the Spitzer data, the Spitzer 3.6 point. And I'd love to, for anyone who has L and T and M data, if there's anything to poke around there with.
Can we go to Davy in the upper echelon? And then I want to throw something out with for chemists too. I don't know if we understand chemistry. I'll just say that. And Davy, here.
So it's Davey Kirkpatrick at Caltech IPAC. And I will say I'm very pleased to see that we're getting all these wonderful spectra from JWST. And a lot of people in this room have been responsible for getting the astrometry so that you guys can predict where those objects are going to be at the time of the JWST observations. But there's a number of these very important objects, the really cold ones like WISO 830, WISO 1446, things like that, where we have a pretty shaky astrometric solution because the citizen scientists of Backyard Worlds found those quite late during the Spitzer mission. And we got whatever data we could as quickly as we could before we shut the mission down. But there's not quite enough data there to have, really precision parallaxes and proper motions. So as you start to push those data out and predicting out to later times than now, so think another 3 or 4 or 5 years, those astrometric uncertainties are going to balloon. And pretty soon, we're not going to get the objects in the slit because they're not even in the acquisition image. So we really need to start thinking about getting astrometry with JWST to really hammer these things down. Plus, the citizen scientists are finding new objects that we don't have any real solid astrometry for yet at all. And we really need to figure out a way to convince the tax, first of all, that these very inefficient observations with JWST need to really happen because we need to get just some quick images, get them repeatedly, get the astrometry, and we'll actually aid further JWST observations to make sure they're successful.
I'll just iterate what Davey's saying. If you're on the TAC, which is gonna happen, 1 to 5 of you will be on it. And I don't know which ones of you, but it's gonna happen. Astrometry shouldn't die because it's gonna be so costly in overhead time at JWST. That is painful, but whatever, it's just gonna have to happen. So vote astrometry. Brittany.
Okay, come on. I think with a lot of results that we've seen today, we're just really impressed with like the signal to noise and everything, but there's still some discrepancies in like different pipelines and like pipeline versions, and there are just small differences that impact some of the smaller, isotopes and other molecules we care about. And so I know we're talking about chemistry, but it's still like on the observers to kind of beat down the systematics a bit. Ben talked about this a little bit in his talk, but I don't think we're done yet with calibrations in the final JWST pipeline. And lastly, if I had to pick only one mode to observe brown dwarfs, it would be MIRI MRS, because that's not something you can do with an ELT. You're not going to spend 100 hours on one Y dwarf to get the R of 1,000. minute for its background.
Elena had a comment, but what you just heard for the 1 to 5 people that are gonna be on the task is hashtag Miri MRS. Please, astrometry, Miri MRS. We need it.
Right, two comments, one related to the astrometry. We have some JWST observations that fail because we don't get the objects on the TA acquisition slip. And part of it is not because people don't know how to calculate the positions given proper motion. It's because the proper motions are not accurate or they don't even exist. So I second that we should do better astrometries. And I second also for the team, NearSpec team in particular, in which I am part of, that we should probably start suggesting observers to do like imaging before they go for spectroscopy, like with maybe with NIRCam, to make sure that your object, you know where your object is before you actually try to take a spectrum, because otherwise it's just tough. And it's not because we are doing a bad job, it's just because the astrometry that we have is the astrometry that we have. That one thing. Regarding the pipeline, I would like to keep everybody, for those that, you know, have no work in instrumentation, we launched, I mean, like a couple of years ago, right? Commissioning finished not even 2 years ago. So calibrations are still being taken regularly. Every cycle we take calibrations. And of course, the calibrations will improve the result of the scientific data. And the same happens with the pipeline. So regarding the pipeline, it has improved a lot over the last year and 2 years and so on. And if you have any questions regarding that, you're welcome to ask me. But it's something still that is working on. And please don't hesitate to send us tickets, because your tickets help us to improve also the pipeline. So we are here to help.
One last point I'll make on this too, since some of us that did cycle 1 data, we had no idea what it was gonna look like when we got it. We had no idea about the calibration. Everybody wants your papers to come out now. But publishing fast is hard when these things like Brittany's talking about, when we're not sure. So that's also just an imploration to the community to just be a little bit patient, as those that are having cycle 1 data take a little bit of extra time to get these papers out, as we're trying to be extremely cautious with it all. Ben, for some last comments, because we're a little bit over, but go ahead, Ben.
Yeah, I just want to make more comments about the data calibration. I think this venue, this conference is excellent for all the brown dwarf scientists. People care about the same science. We should talk if you have data, so that we make sure that we are using a more or less consistent data reduction based on our individual pipeline. That's why I want to bring up this issue. So if you are if you know that any other teams that are doing similar thing, we should all talk, make sure that we agree with each other and we do the best science based on all our, I'm sure we have different approach, but we can be aware of each other doing, and then what to do in our own science, and that make the best brown dwarf science from this calibration. So I think that is what we can do in this Cool Stars meeting. Yeah.
Yes. Well, I love the brown dwarf community and exoplanet community. I love the world community, because people in this room are very kind with each other, very collaborative with each other. So I'm really hoping we do another big push for cycle 4, and we get a large program through. You guys know the exoplanet community got 500 hours to stare at M-dwarf atmosphere rocky planets. Most of what I've seen is flat as a gosh darn pancake. But they got 500 hours. 500. Do you know what we could do with 500 hours? Everything you saw today doesn't even come up to that. Off my soapbox. Let's just have one last round of applause for everybody. Keep talking to each other. Let's get cycle 4 JWST going for the world community. Thank you, everybody. Have fun at dinner.
Poster section now, including the digital posters across the way next to and look. So go over the digital posters and the posters.